Okay, class. So on today's agenda, we're going to discuss the areas of circles. We're going to talk about the sectors of circles. And we're going to talk about the areas of circles in terms of pi, which is very similar to the circumference of a circle in terms of pi. And then we're going to work on worksheet page 695, numbers 3 through 10 and 10 through 18, as well as page 75, numbers 6 through 13 and 1 through 5 on the other side. So let's begin. Here, I have a circle, circle C, with a radius of 4.3 units. And to the left here, I have a formula which we should be familiar with now, the formula for circumference. The circumference is equal to 2 pi times the radius. And notice that it's in blue here, and I've shaded the circumference of the circle here in blue. We said that the circumference is the distance around the circle. It's almost like it's the perimeter of the circle. So if we were going around this track would be gotten by this formula here, which we can multiply 2 times the radius, which is going to give me 8.6 pi. So here's my answer in terms of pi. And if we keep going, we get the circumference, right? 8.6 times 3.14, and there's my circumference. So we've discussed before the circumference in terms of pi and the circumference in terms of just units. And there's no units here, no inches, so I won't put any inches here right now. Okay. Well, the area of a circle is in reference to all of the space inside of the circle. Where the circumference is just the edge, the area is all of the space inside of the circle. And there's a formula for that. Again, it's not a formula that you have to memorize or anything like that because it's on your reference sheet, but it's pretty handy to know what it is off the top of your head. The area of a circle, A, is equal to pi times the radius squared to the second power. So here my radius is 4.3. So the area is going to be pi times 4.3 to the second power. Now 4.3 to the second power does not mean 4.3 times 2. What it means is 4.3 times 4.3. So here's 4.3. I'm going to multiply it by 4.3, which is in essence squaring it, and that's going to give me 18.49. So 4.3 squared is going to give me 18.49. And of course, I have my pi here. Of course, I like to have my number before the variable. And here again, so my area is 18.49 pi. And look at that, I have my area in terms of pi. Again, just like the circumference, this has some very good uses, and we'll get to that later. Of course, if I multiply pi times the, if I multiply 18.49 times pi, I'm going to get the area in regular units, in numbers. So let's do that. Take 18.49, multiply times 3.14, or pi, and that gives me 58.05. So there's the area. And of course, if I wanted to take this area, or any area for that matter, and put it in terms of pi, well, we remember how to do that, right? All I have to do is just take that area and divide it by pi, divided by 3.14, and I get my number, and we put the pi next to it, and that's how we switch back to terms of pi. And that's how we find the area of a circle. And we're going to work on some questions like that later on in class. But now that we've discussed areas, let's talk about sectors of circles. Let's discuss sectors of circles. Well, if an area of a circle is the entire space inside of it, then the sector of a circle would be just a part of all the space inside of it. So a sector is defined as a portion of the area. That's how I would define a sector of a circle. So here I have a circle with a radius of 6 centimeters. And I know that this arc here is 135 degrees. So I know I have a central angle here as well of 135 degrees. And the question becomes, well, what is the area of this sector here? Well, the most important thing that I would probably want to know right now, the first thing that I would want to know other than the radius, since I'm discussing sectors, is what is the area of the circle? What is the area of the circle? So if I look here, here's my formula for area. Let me put this up a little bit higher here. Here's my formula for area. area is equal to pi times r squared. My radius is 6, so it's going to be pi times 6 squared. The area is going to be pi times 6 squared is going to give me 36. It's going to switch it around here so I can put the number in front of it. And maybe, sometimes along the way I'll just skip this part here, but I like, it's a good idea to get into the habit of doing that. So the area in terms of pi is 36 pi. And of course I can keep going, and that'll give me my area in units. So let's take a look here. So it's 36 times 3.14, and the area is 113.04 centimeters squared. So the area of the entire circle, is 113.04. Well, this question is not asking me for the area of the entire circle. It's only asking me for this little sector right here, this portion of it. Well, since it's only asking me for this portion, and this portion is 135 degrees, I'm going to set up a ratio. This is 135 degrees out of 360. And I'm going to multiply that times the area of the circle, which is 113.04. And if you're saying to yourself that this is very similar to finding the arc length, you're right, it is. Because before, it was a ratio of the circumference. Now we're looking for the ratio of the area of the circle. So it's 135 divided by 360 times the area of the entire circle. So when I divide 135 by 360, you're going to get 0.375. Let's do that here. So 135 divided by 360 gives me that decimal there. And I'm going to multiply that, because that's my ratio, that's my percentage, times the entire area. And that's going to give me 42.39 centimeters squared. So this circle has an entire area of 113.04 centimeters squared, but this little sector right here is just 42.39. My ratio of 135 over 360 times the area tells me what the area of this sector is here, 42.39 centimeters squared. Let's look at another example. Here I have a radius, a circle P, with a radius of 3 inches. They tell me that this is a right angle here, so I know that this is 90 degrees. And so is this arc here. Arc CD is also 90 degrees. And they want to know what is the area of this shaded sector here. Well, the first thing that I would want to know is the area of the circle, right? Well, the area, A, is equal to pi r squared. The radius of this circle here is 3, so it's going to be area is equal to pi times 3 squared. Remember that 3 squared is not 6, right, guys? Remember that 3 times 3 is 9. So it's going to be pi times 9, or 9 pi to put it correctly. So my area right here is in terms of pi already. So area is 9 pi. And of course, if I keep going and I multiply, I'm going to get my area in terms of units there. So it's going to be, let's take a look here, 9 times 3.14, and I get an area of 28.26. So there's my area of the entire circle. But I don't want the area of the entire circle. What I do want is the area of this little sector right here. And I know that that's 90 degrees out of how many? Out of 360. And then I'm going to multiply that times the area of the circle, 28.26. 90 out of 360 is a quarter. I multiply them together. Let's take a look here. Right? 90 divided by 360 is 0.25. So I'm going to multiply that by 28.26. And that's going to give me 7.065. So the area of this sector here is 7.06 inches squared, because the area is always going to be in units squared. Okay? Let's take a look at another example. So here we have a circle with a radius of 17 feet, an arc of 52 degrees, and they're asking us to find the area of this sector here. Take a minute to figure that out on your own, and let's see what you get. So you try it now. Okay, so hopefully everyone had a chance to try that problem there. Since I'm talking about a sector here, the first thing that I'm going to want to know is what is the area of the circle. I'm going to want to know what is the area. Well, the formula for the area is pi times r squared. The radius is 17, so my area is going to be pi times 17 to the second power. That means that doesn't mean 17 times 2, it means 17 times 17. That's squaring it. So when I do 17 times 17, that gives me 289. So the area, so the area is pi times 289, or 289 pi. And look, here I have my area in terms of pi. Of course, when I multiply them together, I'm going to get the area in terms of units, and I get 904.46. This should be feet, by the way. I'm sorry, not inches, because my radius is in feet, so this should be in feet squared. So my area is 904.46 feet squared. But remember, that's the area of the entire circle. They don't want that. They're asking for this little portion here. Well, I know that this little sector here is only 52 degrees wide. So it's going to be 52 degrees out of 360, that's my ratio, times the entire area. When I divide 52 by 360, I get this decimal here in my calculator. 52 divided by 360, I get that decimal there. And I'm going to multiply that times the entire area of the circle, 904.46, and that's going to give me 130.64. So the area of this little sector right here is 130.64. Let's try another one together. Here's another circle with a radius of 5, and this arc here is 160 degrees, and they want the shaded sector here. Take a second to figure that out. What is the area of this shaded sector here? Okay, well, the first thing you should figure out was what's the area of the entire circle. So here's my formula for area. Area is equal to pi r squared. The radius is 5, so it's going to be pi times 5 squared. 5 squared is 25, so my area is going to be 25 times pi. I just rearranged it here a little bit to have the number first. That's just me. So my area is 25 pi in terms of pi. And if I multiply pi times 25, I get the area is 78.5 meters squared. But remember, that's the area of what? Of the entire circle. They only want the shaded region here, right? Well, it's 160 degrees, so my central angle here is also 160 degrees, so I can make a ratio. My ratio is going to be 160 out of 360 times the area of the entire thing. When I do that, I get a decimal. I multiply these two together, and I get 34.88 meters squared.